Welcome, everyone, to a soothing journey into the intricate world of environmental chemistry. Tonight, we delve into the pervasive yet often unseen threats of microplastics and forever chemicals, exploring their sources, pathways, and impacts on our planet and our health. Prepare to be both informed and relaxed as we uncover the science behind these emerging contaminants, offering a perspective that is both enlightening and calming, perfect for easing into a restful night's sleep. Our exploration begins with microplastics, tiny plastic particles less than 5 millimeters in diameter. These fragments originate from a variety of sources, including the breakdown of larger plastic debris, industrial processes, and the direct release of microbads for personal care products. Consider, for example, the simple act of washing a synthetic fleece jacket. Each wash cycle can release thousands of microplastic fibers into the wastewater stream, which eventually find their way into rivers, lakes, and oceans. Similarly, the abrasion of car tires on roadways generates microplastic particles that are carried by rainwater into nearby waterways. These seemingly insignificant particles accumulate over time, creating a pervasive form of pollution that affects ecosystems worldwide. To illustrate further, imagine a bustling city street after a heavy rain. The runoff carries with it a cocktail of pollutants, including microplastics shed from tires, plastic packaging, and construction materials. These particles travel through storm drains and into local rivers, where they become part of a complex ecological web. Fish and other aquatic organisms ingest these microplastics, mistaking them for food. As these organisms are consumed by larger predators, the microplastics accumulate up the food chain, potentially reaching humans who consume seafood. This process, known as biomagnification, amplifies the concentration of microplastics in higher trophic levels, raising concerns about the long-term impacts on both wildlife and human health. Now, let's turn our attention to forever chemicals, a group of synthetic compounds known as per and polyfluoroalkyl substances, PFAS. These chemicals are characterized by their strong carbon-fluorine bonds, which make them exceptionally resistant to degradation in the environment. PFAS are used in a wide range of products, including non-stick cookware, firefighting foam, and food packaging, due to their water and grease-repellent properties. However, their persistence and mobility have led to widespread contamination of water, air, and soil. Consider the case of a community located near a former military base, where firefighting foam containing PFAS was used extensively for training exercises. Over time, the PFAS seeped into the groundwater, contaminating the local drinking water supply. Residents who consumed this water were exposed to elevated levels of PFAS, which have been linked to a variety of health problems, including liver damage, immune system dysfunction, and certain types of cancer. This example highlights the potential for PFAS to migrate long distances and persist in the environment for decades, posing a long-term threat to public health. To further illustrate the persistence of PFAS, imagine a pristine mountain stream far from any industrial activity. Despite its remote location, the stream may still contain detectable levels of PFAS due to atmospheric deposition. PFAS can be transported through the air via dust particles and precipitation, allowing them to reach even the most remote corners of the globe. This widespread distribution underscores the challenges of managing and mitigating PFAS contamination, as it requires a comprehensive approach that addresses both point sources and diffuse sources of pollution. The journey of microplastics and forever chemicals through water begins with their release into the environment. Microplastics enter waterways through wastewater discharge, stormwater runoff, and direct littering. Once in the water, they can travel long distances, carried by currents and tides. Similarly, PFAS enter water through industrial discharges, spills, and the leaching of contaminated soil. Their high solubility and persistence allow them to spread rapidly, affecting both surface water and groundwater resources. Imagine a river flowing through an industrial area. Along its banks, factories release wastewater containing a variety of pollutants, including microplastics and PFAS. As the river meanders downstream, these contaminants mix with the water, spreading throughout the aquatic ecosystem. Fish and other aquatic organisms ingest the contaminated water, accumulating these pollutants in their tissues. The river eventually empties into the ocean, carrying its burden of microplastics and PFAS into the marine environment, where they can affect marine life and potentially enter the human food chain. The movement of microplastics and forever chemicals through air is equally concerning. Microplastics can become airborne through wind erosion of contaminated soil, the burning of plastic waste, and the release of fibers from textiles. PFAS can volatilize from contaminated water and soil, entering the atmosphere as gaseous compounds. Once airborne, these pollutants can travel long distances, affecting air quality and potentially depositing in remote areas. Consider a large-scale incineration facility that burns municipal solid waste. The combustion process releases a plume of smoke containing a variety of pollutants, including microplastics and PFAS. These airborne particles and gases can be carried by the wind for hundreds or even thousands of miles, affecting air quality in distant communities. Similarly, dust storms in arid regions can transport microplastics from contaminated soil, spreading them across vast areas. This highlights the interconnectedness of air and water pollution, as pollutants released into one medium can easily transfer to the other. The impacts of microplastics and forever chemicals on ecosystems are wide-ranging and complex. Microplastics can physically harm aquatic organisms, causing blockages in their digestive systems and reducing their ability to feed. They can also act as vectors for other pollutants, absorbing harmful chemicals from the surrounding water and transferring them to organisms that ingest them. PFAS can disrupt the endocrine systems of wildlife, affecting their reproduction, development, and immune function. Imagine a seabird that has ingested a large number of microplastics. The plastics fill its stomach, giving it a false sense of fullness and reducing its appetite for nutritious food. Over time, the bird becomes malnourished and weakened, making it more vulnerable to disease and predation. Similarly, consider a fish that has been exposed to PFAS. The chemicals disrupt its hormone balance, affecting its ability to reproduce and maintain a healthy immune system. These examples illustrate the potential for microplastics and PFAS to cause significant harm to wildlife populations. The effects of microplastics and forever chemicals on human health are still being investigated, but emerging evidence suggests that they may pose a variety of risks. Microplastics can enter the human body through ingestion, inhalation, and dermal contact. They have been found in human blood, lung tissue, and placenta, raising concerns about their potential to accumulate in the body and cause harm. PFAS have been linked to a variety of health problems, including liver damage, immune system dysfunction, thyroid disorders, and certain types of cancer. Imagine a family that regularly consumes drinking water contaminated with PFAS. Over time, the chemicals accumulate in their bodies, increasing their risk of developing health problems. The children in the family may be particularly vulnerable, as PFAS can interfere with their development and immune function. Similarly, consider a worker in a plastics manufacturing plant who is exposed to high levels of microplastics through inhalation. The microplastics may irritate their lungs and increase their risk of developing respiratory problems. These examples highlight the potential for microplastics and PFAS to pose significant risks to human health. Addressing the challenges posed by microplastics and forever chemicals requires a multifaceted approach that includes reducing their release into the environment, developing effective remediation technologies, and implementing stricter regulations. Reducing plastic consumption, improving wastewater treatment, and phasing out the use of PFAS in consumer products are all important steps in preventing further contamination. Developing technologies to remove microplastics and PFAS from water and soil is also crucial for cleaning up existing pollution. Imagine a future where plastic waste is minimized through widespread adoption of reusable products and effective recycling programs. Wastewater treatment plants are equipped with advanced filtration systems that remove microplastics and PFAS before they can enter waterways. Stricter regulations limit the use of PFAS in consumer products and require manufacturers to properly dispose of these chemicals. These measures would significantly reduce the release of microplastics and forever chemicals into the environment, protecting ecosystems and human health. To further illustrate the potential for positive change, consider the example of a community that has implemented a comprehensive plastic reduction program. The program includes public awareness campaigns, incentives for using reusable bags and containers, and bans on single-use plastic items. As a result, the amount of plastic waste generated in the community has decreased significantly, reducing the amount of microplastics entering waterways. This example demonstrates the power of collective action in addressing the challenges posed by microplastics and other emerging contaminants. As we conclude our exploration of microplastics and forever chemicals, it is important to remember that these are complex and evolving issues. While the science is still emerging, it is clear that these contaminants pose a significant threat to our planet and our health. By understanding their sources, pathways, and impacts, we can take informed action to reduce their release into the environment and protect ourselves and future generations. Let's delve deeper into the sources of microplastics. Beyond the breakdown of larger plastics, significant quantities of microplastics originate from textiles. Synthetic fabrics like polyester, nylon, and acrylic shed microfibers during washing. These microfibers are often too small for wastewater treatment plants to filter out effectively, leading to their release into rivers and oceans. A single load of laundry can release hundreds of thousands of microfibers, contributing significantly to microplastic pollution. Consider the fashion industry, which relies heavily on synthetic fabrics. The production, use, and disposal of these fabrics contribute to a continuous stream of microplastic pollution. Fast fashion, with its emphasis on cheap, disposable clothing, exacerbates the problem. Consumers are encouraged to buy more clothes, which are often worn only a few times before being discarded. This cycle of consumption and disposal leads to a massive accumulation of textile waste, much of which ends up in landfills or incinerators, further releasing microplastics into the environment. To put this into perspective, imagine a landfill overflowing with discarded clothing. As the fabrics decompose, they release microplastics into the surrounding soil and water. Rainwater carries these microplastics into nearby streams and rivers, eventually transporting them to the ocean. The sheer volume of textile waste generated each year makes this a significant source of microplastic pollution, highlighting the need for more sustainable practices in the fashion industry. Another significant source of microplastics is the abrasion of tires on roadways. As vehicles travel, their tires wear down, releasing tiny particles of rubber and plastic into the air and onto the road surface. These particles are then washed away by rainwater, entering waterways and contributing to microplastic pollution. The problem is particularly acute in urban areas with heavy traffic volumes. Imagine a busy highway with thousands of vehicles traveling at high speeds. The constant friction between the tires and the road surface generates a cloud of microscopic particles, including microplastics. These particles settle on the road surface and are eventually washed away by rain, entering storm drains and flowing into rivers and lakes. The cumulative effect of this tire wear is a significant source of microplastic pollution, particularly in densely populated areas. To illustrate further, consider the impact of a single vehicle traveling a long distance. Over the course of a cross-country road trip, a car's tires can shed a significant amount of microplastic particles. These particles are dispersed along the route, contaminating the soil and water in numerous locations. The collective impact of millions of vehicles traveling billions of miles each year is a substantial source of microplastic pollution, highlighting the need for more durable and sustainable tire materials. Let's now turn our attention to the pathways of forever chemicals. PFAS can contaminate water through various routes, including industrial discharges, spills, and the leaching of contaminated soil. Industrial facilities that manufacture or use PFAS can release these chemicals into wastewater, which may then enter rivers, lakes, and groundwater. Accidental spills of PFAS-containing materials can also lead to localized contamination of soil and water. Imagine a chemical plant that produces non-stick cookware. The manufacturing process involves the use of PFAS, which are applied to the cookware to create a non-stick surface. Wastewater from the plant may contain residual PFAS, which can be released into a nearby river. Over time, the PFAS accumulate in the river sediment and contaminate the water, affecting aquatic life and potentially entering the human food chain. To further illustrate, consider the impact of firefighting foam containing PFAS. This foam is used extensively to extinguish fires, particularly at airports and military bases. When the foam is sprayed onto the ground, the PFAS can seep into the soil and groundwater, contaminating local water supplies. This has led to widespread contamination of drinking water in communities located near these facilities, raising concerns about the long-term health effects of PFAS exposure. The movement of PFAS through the air is another important pathway of contamination. PFAS can volatilize from contaminated water and soil, entering the atmosphere as gaseous compounds. They can also be transported through the air via dust particles and precipitation. This allows them to reach even the most remote corners of the globe, affecting air quality and potentially depositing in remote areas. Consider a large lake contaminated with PFAS. The chemicals can evaporate from the water surface, entering the atmosphere as gaseous compounds. These compounds can then be transported by the wind over long distances, affecting air quality in distant communities. Similarly, dust storms in arid regions can transport PFAS from contaminated soil, spreading them across vast areas. This highlights the interconnectedness of air and water pollution, as PFAS released into one medium can easily transfer to the other. To put this into perspective, imagine a remote mountain lake far from any industrial activity. Despite its pristine appearance, the lake may still contain detectable levels of PFAS due to atmospheric deposition. The chemicals have been transported through the air from distant sources, highlighting the global reach of PFAS contamination. This underscores the challenges of managing and mitigating PFAS pollution, as it requires a comprehensive approach that addresses both local and global sources. Let's explore the impacts of microplastics on aquatic ecosystems in more detail. Microplastics can physically harm aquatic organisms, causing blockages in their digestive systems and reducing their ability to feed. Small organisms like zooplankton and filter feeders can ingest microplastics, mistaking them for food. This can lead to starvation and reduced growth rates, affecting the entire food web. Imagine a tiny zooplankton that has ingested a microplastic particle. The plastic fills its stomach, giving it a false sense of fullness and reducing its appetite for nutritious food. Over time, the zooplankton becomes malnourished and weakened, making it more vulnerable to predation. This can have cascading effects on the entire ecosystem, as zooplankton are a critical food source for many larger organisms. To further illustrate, consider the impact of microplastics on filter feeders like mussels and oysters. These organisms filter large volumes of water to obtain food, and they inevitably ingest microplastics along with their natural prey. The microplastics can accumulate in their tissues, potentially affecting their health and reproductive capacity. This can have significant economic consequences for aquaculture industries that rely on these organisms. Microplastics can also act as vectors for other pollutants, absorbing harmful chemicals from the surrounding water and transferring them to organisms that ingest them. Many organic pollutants, such as pesticides and PCBs, are hydrophobic and tend to bind to plastic surfaces. When organisms ingest microplastics, they also ingest these adsorbed pollutants, increasing their exposure to harmful chemicals. Imagine a microplastic particle floating in a polluted river. The particle adsorbs a variety of toxic chemicals from the surrounding water, becoming a concentrated source of pollution. When a fish ingests the microplastic, it also ingests the adsorbed chemicals, increasing its exposure to these harmful substances. This can lead to a variety of health problems, including liver damage, immune system dysfunction, and reproductive impairment. To put this into perspective, consider the impact of microplastics on seabirds. Seabirds often ingest plastic debris, mistaking it for food. The plastics can accumulate in their stomachs, causing blockages and reducing their ability to feed. In addition, the plastics can adsorb harmful chemicals from the surrounding water, increasing the bird's exposure to toxins. This can lead to a variety of health problems, including reduced growth rates, impaired immune function, and reproductive failure. Now, let's delve deeper into the effects of forever chemicals on wildlife. PFAS can disrupt the endocrine systems of wildlife, affecting their reproduction, development, and immune function. The endocrine system is a complex network of glands that produce hormones, which regulate a wide range of physiological processes. PFAS can interfere with hormone signaling, disrupting these processes and leading to a variety of adverse effects. Imagine a fish that has been exposed to PFAS. The chemicals disrupt its hormone balance, affecting its ability to reproduce and maintain a healthy immune system. The fish may experience reduced fertility, abnormal development, and increased susceptibility to disease. These effects can have significant consequences for fish populations, particularly in areas with high levels of PFAS contamination. To further illustrate, consider the impact of PFAS on amphibians like frogs and salamanders. Amphibians are particularly sensitive to environmental pollutants because they have permeable skin and spend part of their lives in water. PFAS can disrupt their endocrine systems, affecting their development and reproduction. This can lead to declines in amphibian populations, which are already threatened by habitat loss and other environmental stressors. The effects of PFAS on human health are a growing concern. Studies have linked PFAS exposure to a variety of health problems, including liver damage, immune system dysfunction, thyroid disorders, and certain types of cancer. PFAS can accumulate in the body over time, increasing the risk of adverse health effects. Children are particularly vulnerable to PFAS exposure, because they have developing immune systems and may be exposed to higher levels of PFAS through contaminated drinking water and food. Imagine a community that regularly consumes drinking water contaminated with PFAS. Over time, the chemicals accumulate in their bodies, increasing their risk of developing health problems. The children in the community may be particularly vulnerable, as PFAS can interfere with their development and immune function. This can lead to a variety of health problems, including reduced vaccine effectiveness and increased susceptibility to infectious diseases. To put this into perspective, consider the impact of PFAS on pregnant women. PFAS can cross the placenta and expose the developing fetus to these chemicals. This can lead to a variety of adverse health effects in the child, including reduced birth weight, immune system dysfunction, and developmental delays. This highlights the importance of reducing PFAS exposure, particularly for pregnant women and young children. Addressing the challenges posed by microplastics and forever chemicals requires a comprehensive and coordinated effort. Reducing plastic consumption, improving wastewater treatment, and phasing out the use of PFAS in consumer products are all important steps in preventing further contamination. Developing technologies to remove microplastics and PFAS from water and soil is also crucial for cleaning up existing pollution. In addition, stricter regulations are needed to limit the release of these chemicals into the environment and protect public health. Imagine a future where plastic waste is minimized through widespread adoption of reusable products and effective recycling programs. Wastewater treatment plants are equipped with advanced filtration systems that remove microplastics and PFAS before they can enter waterways. Stricter regulations limit the use of PFAS in consumer products and require manufacturers to properly dispose of these chemicals. These measures would significantly reduce the release of microplastics and forever chemicals into the environment, protecting ecosystems and human health. To further illustrate the potential for positive change, consider the example of a community that has implemented a comprehensive plastic reduction program. The program includes public awareness campaigns, incentives for using reusable bags and containers, and bans on single-use plastic items. As a result, the amount of plastic waste generated in the community has decreased significantly, reducing the amount of microplastics entering waterways. This example demonstrates the power of collective action in addressing the challenges posed by microplastics and other emerging contaminants. Let's delve into the regulatory landscape surrounding PFAS. In recent years, there has been growing awareness of the risks posed by PFAS, leading to increased regulatory scrutiny. Several states have established drinking water standards for PFAS, limiting the amount of these chemicals that can be present in public water supplies. The U.S. Environmental Protection Agency, EPA, has also taken action to address PFAS contamination, including issuing health advisories and developing a national strategy for managing these chemicals. Imagine a state that has established a strict drinking water standard for PFAS. The standard requires public water systems to monitor for PFAS and take steps to reduce levels if they exceed the limit. This provides a strong incentive for water systems to invest in treatment technologies that can remove PFAS from drinking water, protecting public health. To further illustrate, consider the EPA's national strategy for managing PFAS. The strategy includes a number of key actions, such as establishing a national drinking water standard for PFAS, designating certain PFAS as hazardous substances under the Superfund law, and developing new technologies for removing PFAS from water and soil. This comprehensive approach aims to address PFAS contamination across the country and protect public health and the environment. In addition to regulatory actions, there is also a growing effort to develop innovative technologies for removing microplastics and PFAS from water and soil. These technologies include advanced filtration systems, activated carbon adsorption, and bioremediation. Advanced filtration systems can remove microplastics from water by physically trapping the particles. Activated carbon adsorption can remove PFAS from water by binding the chemicals to the surface of the carbon. Bioremediation uses microorganisms to break down PFAS into less harmful substances. Imagine a wastewater treatment plant that has installed an advanced filtration system to remove microplastics from its effluent. The system consists of a series of filters that trap microplastic particles of various sizes. As the water passes through the filters, the microplastics are removed, resulting in cleaner water that is discharged into the environment. This technology can significantly reduce the amount of microplastics entering waterways from wastewater treatment plants. To further illustrate, consider the use of bioremediation to clean up PFAS-contaminated soil. The soil is treated with microorganisms that can break down PFAS into less harmful substances. Over time, the microorganisms degrade the PFAS, reducing the concentration of these chemicals in the soil. This technology can be used to clean up contaminated sites and prevent PFAS from leaching into groundwater. As we conclude our exploration of microplastics and forever chemicals, it is important to remember that these are complex and evolving issues. While the science is still emerging, it is clear that these contaminants pose a significant threat to our planet and our health. By understanding their sources, pathways, and impacts, we can take informed action to reduce their release into the environment and protect ourselves and future generations. It requires continuous learning, adaptation, and collaboration to effectively address these challenges and ensure a healthier future for all. Let's consider the role of individual actions in addressing microplastic and PFAS pollution. While large-scale solutions, such as regulations and technological innovations, are crucial, individual choices and behaviors can also make a significant difference. Simple actions like reducing plastic consumption, choosing products without PFAS, and properly disposing of waste can collectively contribute to a cleaner and healthier environment. Imagine a household that consciously reduces its plastic consumption. The family uses reusable shopping bags, water bottles, and food containers. They avoid single-use plastic items whenever possible and choose products with minimal packaging. By making these small changes, the family significantly reduces its contribution to plastic waste and microplastic pollution. To further illustrate, consider a consumer who carefully selects products without PFAS. They avoid non-stick cookware made with Teflon and choose food packaging that is not treated with PFAS. They also opt for personal care products that are free of PFAS. By making these informed choices, the consumer reduces their exposure to PFAS and supports companies that are committed to producing safer products. The importance of proper waste disposal cannot be overstated. Improperly disposed of plastic waste can easily end up in waterways, contributing to microplastic pollution. Similarly, improper disposal of product containing PFAS can lead to contamination of soil and groundwater. By properly disposing of waste and participating in recycling programs, individuals can help prevent these pollutants from entering the environment. Imagine a community that has a well-organized recycling program. Residents are educated about what can and cannot be recycled, and they diligently sort their waste. The recycled materials are then processed and used to make new products, reducing the need for virgin materials and minimizing waste. This community demonstrates the power of collective action in promoting sustainable waste management practices. To put this into perspective, consider the impact of a single person who litters. A discarded plastic bottle or cigarette, but can easily end up in a storm drain, eventually making its way to a river or ocean. Over time, the plastic breaks down into microplastics, contributing to pollution. By simply disposing of waste properly, individuals can prevent this from happening and help protect the environment. Education and awareness are also key to addressing microplastic and PFAS pollution. By learning about the sources, pathways, and impacts of these pollutants, individuals can make informed decisions and take action to reduce their exposure and minimize their contribution to the problem. Schools, community organizations, and the media all have a role to play in raising awareness and promoting sustainable practices. Imagine a school that incorporates environmental education into its curriculum. Students learn about the sources of pollution, the impacts on ecosystems and human health, and the steps they can take to reduce their environmental footprint. They participate in projects such as cleaning up local parks and streams, planting trees, and promoting recycling. This instills in them a sense of environmental responsibility and empowers them to become agents of change. To further illustrate, consider the role of the media in raising awareness about microplastic and PFAS pollution. News articles, documentaries, and social media campaigns can inform the public about the risks posed by these pollutants and the actions that can be taken to address them. By providing accurate and accessible information, the media can help to empower individuals to make informed decisions and take action to protect the environment. Governments also play a crucial role in addressing microplastic and PFAS pollution. By enacting and enforcing regulations, governments can limit the use of these pollutants in products and processes, promote the development of safer alternatives, and ensure that waste is managed properly. They can also invest in research and development to better understand the sources, pathways, and impacts of these pollutants, and to develop effective strategies for mitigating their effects. Imagine a government that implements a comprehensive plan to reduce microplastic and PFAS pollution. The plan includes regulations that limit the use of PFAS in food packaging and personal care products, as well as requirement for manufacturers to properly dispose of waste containing these chemicals. The government also invests in research to develop safer alternatives to PFAS and to improve wastewater treatment technologies. This demonstrates the power of government action in protecting the environment and human health. To further illustrate, consider the role of international cooperation in addressing microplastic and PFAS pollution. These pollutants can travel long distances through air and water, meaning that they can affect countries far from their sources. International agreements and collaborations are needed to coordinate efforts to reduce the use of these pollutants, monitor their presence in the environment, and develop effective strategies for mitigating their impacts. By working together, countries can achieve more than they could alone in protecting the global environment. The role of technology in addressing microplastic and PFAS pollution is also significant. Advances in materials science, chemistry, and engineering are leading to the development of new technologies for removing these pollutants from water and air, as well as for creating safer alternatives to PFAS and microplastics. For example, researchers are developing new filtration systems that can effectively remove microplastics from wastewater, as well as new materials that can be used to replace PFAS in non-stick cookware. Imagine a city that implements a state-of-the-art wastewater treatment plant that is capable of removing microplastics and PFAS from the water. The plant uses a combination of filtration, adsorption, and biological treatment processes to ensure that the water discharged back into the environment is free of these pollutants. This demonstrates the power of technology in addressing environmental challenges and protecting water resources. To further illustrate, consider the role of citizen science in monitoring microplastic and PFAS pollution. Citizen scientists are volunteers who collect and analyze data on environmental issues, such as the presence of microplastics in local waterways. By engaging in citizen science projects, individuals can contribute to scientific research, raise awareness about environmental issues, and help to inform policy decisions. This demonstrates the power of community involvement in addressing environmental challenges. The ethical considerations surrounding microplastic and PFAS pollution are also important to consider. The use of these pollutants in products and processes can have significant impacts on human health and the environment, raising questions about the responsibility of manufacturers, governments, and individuals to minimize these impacts. Ethical considerations also arise in the development and implementation of solutions to these problems, such as the need to ensure that solutions are equitable and do not disproportionately burden vulnerable populations. Imagine a company that voluntarily chooses to phase out the use of PFAS in its products, even though it is not legally required to do so. The company recognizes the potential health and environmental risks associated with PFAS and believes that it has a moral obligation to protect its customers and the environment. This demonstrates the power of ethical decision-making in promoting sustainability and protecting human health. To further illustrate, consider the ethical implications of exporting products containing PFAS to developing countries. While these products may be legal in the exporting country, they may pose significant health and environmental risks in the importing country, which may lack the resources to properly manage them. This raises questions about the responsibility of exporting countries to ensure that their products do not harm the environment or human health in other countries. The long-term consequences of microplastic and PFAS pollution are still not fully understood. These pollutants can persist in the environment for decades or even centuries, potentially causing long-term damage to ecosystems and human health. Continued research is needed to better understand the long-term impacts of these pollutants and to develop effective strategies for mitigating their effects. This includes studying the effects of chronic exposure to low levels of these pollutants on human health, as well as the effects on ecosystems and wildlife. Imagine a future in which microplastic and PFAS pollution have caused widespread damage to ecosystems and human health. Fish populations have declined due to the ingestion of microplastics, and human health problems such as cancer and immune system dysfunction have become more common due to exposure to PFAS. This illustrates the potential long-term consequences of failing to address these environmental challenges effectively. To further illustrate, consider the potential impact of microplastic and PFAS pollution on future generations. If we fail to address these problems now, we may be leaving a legacy of environmental damage and health problems for future generations to deal with. This raises questions about our responsibility to protect the environment and human health for the benefit of those who will come after us. The economic implications of microplastic and PFAS pollution are also significant. The costs of cleaning up contaminated sites, treating water supplies, and addressing health problems associated with exposure to these pollutants can be substantial. Additionally, the economic value of ecosystem services, such as clean water and healthy fisheries, can be diminished by microplastic and PFAS pollution. Investing in prevention and mitigation measures can be more cost-effective in the long run than dealing with the consequences of pollution. Imagine a community that has to shut down its drinking water supply due to PFAS contamination. The community must then spend millions of dollars to install a new water treatment system or find an alternative source of water. This illustrates the economic costs associated with PFAS pollution and the importance of preventing contamination in the first place. To further illustrate, consider the potential impact of microplastic pollution on the tourism industry. If beaches and coastal waters become heavily polluted with microplastics, tourists may be less likely to visit, leading to a decline in tourism revenue. This demonstrates the economic value of protecting the environment and preventing pollution. The social justice implications of microplastic and PFAS pollution are also important to consider. Low-income communities and communities of color are often disproportionately exposed to these pollutants due to the location of industrial facilities and waste disposal sites. Addressing these environmental justice issues requires ensuring that all communities have equal access to clean air, clean water, and a healthy environment. This includes involving affected communities in decision-making processes and prioritizing the cleanup of contaminated sites in disadvantaged areas. Imagine a community located near a manufacturing plant that releases PFAS into the air and water. The residents of this community, who are primarily low-income and people of color, are exposed to high levels of PFAS, leading to increased rates of cancer and other health problems. This illustrates the environmental injustice associated with PFAS pollution and a need to protect vulnerable communities from exposure to environmental hazards. To further illustrate, consider the legacy of industrial pollution in many urban areas. Historically, industrial facilities have been disproportionately located in low-income communities and communities of color, leading to a legacy of soil, water, and air contamination. Addressing these environmental justice issues requires investing in the cleanup of contaminated sites and ensuring that all communities have access to a healthy environment. The role of individual actions in addressing microplastic and PFAS pollution is also important. While governments, businesses, and organizations have a crucial role to play, individuals can also make a difference by reducing their consumption of single-use plastics, avoiding products containing PFAS, properly disposing of waste, and supporting policies that promote sustainability. Collective action by individuals can have a significant impact on reducing pollution and protecting the environment. Imagine a group of friends who decide to reduce their use of single-use plastics. They start bringing reusable shopping bags to the grocery store, using reusable water bottles instead of buying bottled water, and packing their lunches in reusable containers. By making these small changes, they collectively reduce their consumption of single-use plastics and help to minimize microplastic pollution. To further illustrate, consider the impact of a consumer who chooses to buy products made from recycled materials. By supporting companies that use recycled materials, the consumer helps to create a market for recycled products and reduces the demand for virgin materials. This can help to conserve resources and minimize waste. The importance of interdisciplinary collaboration in addressing microplastic and PFAS pollution cannot be overstated. These are complex problems that require expertise from a variety of fields, including chemistry, engineering, toxicology, environmental science, public health, and policy. By working together, experts from different disciplines can develop more comprehensive and effective solutions to these challenges. Imagine a team of scientists, engineers, and policymakers working together to develop a new technology for removing PFAS from drinking water. The scientists conduct research to understand the chemical properties of PFAS and identify potential removal methods. The engineers design and build a treatment system based on the scientific findings. The policymakers develop regulations to ensure that the technology is implemented effectively and that the water supply is protected. This illustrates the power of interdisciplinary collaboration in addressing complex environmental challenges. To further illustrate, consider the role of community organizations in addressing microplastic and PFAS pollution. These organizations can bring together residents, businesses, and government agencies to develop and implement solutions that are tailored to the specific needs of the community. They can also provide education and outreach to raise awareness about these issues and promote sustainable practices. The ongoing research into microplastic and PFAS pollution is essential for understanding the full extent of the problem and developing effective solutions. Scientists are continuing to study the sources, pathways, and impacts of these pollutants, as well as developing new technologies for removing them from the environment and creating safer alternatives. Continued investment in research is crucial for protecting human health and the environment. This includes research into the effects of microplastics on marine life, the transport of PFAS through the atmosphere, and the effectiveness of different treatment technologies for removing these pollutants from water. Imagine a team of researchers conducting a long-term study on the effects of microplastic ingestion on fish populations. The researchers collect data on fish health, behavior, and reproduction in areas with high and low levels of microplastic pollution. The results of the study provide valuable insights into the ecological impacts of microplastics and help to inform management decisions. To further illustrate, consider the role of academic institutions in conducting research on microplastic and PFAS pollution. Universities and colleges are often at the forefront of scientific research, conducting studies on a wide range of environmental issues. They also play a role in training the next generation of scientists and engineers who will be needed to address these challenges. The need for global action to address microplastic and PFAS pollution is clear. These pollutants are found in every corner of the globe, and their impacts are felt by people and ecosystems around the world. International cooperation is essential for coordinating efforts to reduce the use of these pollutants, monitor their presence in the environment, and develop effective strategies for mitigating their effects. This includes sharing information, developing common standards, and providing financial and technical assistance to developing countries. Imagine a global agreement to phase out the use of PFAS in consumer products. The agreement sets targets for reducing PFAS production and consumption, as well as requirements for manufacturers to disclose the presence of PFAS in their products. This illustrates the power of international cooperation in addressing global environmental challenges. To further illustrate, consider the role of international organizations in coordinating efforts to address microplastic and PFAS pollution. Organizations such as the United Nations Environment Program, UNEP, and the World Health Organization, WHO, can play a key role in bringing together countries, businesses, and organizations to develop and implement solutions to these problems. The potential for innovation in addressing microplastic and PFAS pollution is vast. New technologies are being developed all the time for removing these pollutants from the environment, creating safer alternatives, and promoting sustainable practices. By fostering innovation and investing in research and development, we can accelerate the transition to a cleaner and healthier future. This includes developing new materials that are biodegradable or compostable, designing products that are easier to recycle, and creating new business models that prioritize sustainability. Imagine a startup company that develops a new material that can be used to replace plastic in packaging. The material is made from renewable resources and is fully biodegradable, meaning that it will break down naturally in the environment. This illustrates the potential for innovation to solve environmental problems and create new economic opportunities. To further illustrate, consider the role of venture capital in funding innovative solutions to microplastic and PFAS pollution. Investors are increasingly recognizing the potential for businesses that are developing sustainable solutions to environmental challenges, and they're providing funding to help these businesses grow and scale their impact. The importance of continuous monitoring and assessment of microplastic and PFAS pollution cannot be overstated. It is essential to track the levels of these pollutants in the environment, assess their impacts on human health and ecosystems, and evaluate the effectiveness of different mitigation measures. This information is needed to inform policy decisions and ensure that we are making progress towards a cleaner and healthier future. This includes monitoring the levels of microplastics in rivers, lakes, and oceans, assessing the exposure of wildlife to PFAS, and tracking the incidence of health problems associated with exposure to these pollutants. Imagine a government agency that conducts regular monitoring of PFAS levels in drinking water supplies. The agency uses sophisticated analytical techniques to detect even trace amounts of PFAS and takes action to address any contamination that is found. This illustrates the importance of continuous monitoring in protecting public health. To further illustrate, consider the role of citizen science in monitoring microplastic and PFAS pollution. Volunteers can collect samples of water, soil, and air and send them to laboratories for analysis. This can help to expand the reach of monitoring efforts and engage the public in environmental protection. The need for a shift toward a circular economy is becoming increasingly clear. A circular economy is one in which resources are used more efficiently and waste is minimized. This involves designing products that are durable, reparable, and recyclable, as well as developing systems for collecting and reusing materials. By shifting towards a circular economy, we can reduce our reliance on virgin materials and minimize the amount of waste that ends up in the environment. This includes designing products that are easy to disassemble and recycle, developing systems for collecting and reusing plastic waste, and promoting the use of recycled materials in manufacturing. Imagine a city that implements a comprehensive waste management program that focuses on reducing, reusing, and recycling. The city provides residents with convenient access to recycling facilities, composts organic waste, and promotes the use of reusable containers and bags. This illustrates the potential of a circular economy to reduce waste and conserve resources. To further illustrate, consider the role of businesses in promoting a circular economy. Companies can design products that are durable, reparable, and recyclable, as well as offering services such as product take-back programs and repair services. This can help to reduce waste and create new economic opportunities. The role of education and public awareness in addressing microplastic and PFAS pollution is crucial. Many people are not aware of the sources, pathways, and impacts of these pollutants, or the steps they can take to reduce their exposure and minimize their contribution to the problem. By raising awareness and providing accurate information, we can empower individuals to make informed decisions and take action to protect the environment. This includes educating people about the risks of single-use plastics, the benefits of using reusable products, and the importance of proper waste disposal. Imagine a school that incorporates environmental education into its curriculum. Students learn about the sources of pollution, the impacts on ecosystems and human health, and the steps they can take to reduce their environmental footprint. They participate in projects such as cleaning up local parks and streams, planting trees, and promoting recycling. This instills in them a sense of environmental responsibility and empowers them to become agents of change. To further illustrate, consider the role of the media in raising awareness about microplastic and PFAS pollution. News articles, documentaries, and social media campaigns can inform the public about the risks posed by these pollutants and the actions that can be taken to address them. By providing accurate and accessible information, the media can help to empower individuals to make informed decisions and take action to protect the environment. The importance of government regulations in addressing microplastic and PFAS pollution cannot be overstated. Regulations can limit the use of these pollutants in products and processes, promote the development of safer alternatives, and ensure that waste is managed properly. They can also provide incentives for businesses to adopt sustainable practices and hold polluters accountable for their actions. This includes setting limits on the amount of PFAS that can be released into the environment, requiring manufacturers to disclose the presence of PFAS in their products, and establishing standards for the treatment of contaminated water. Imagine a government that implements a comprehensive plan to reduce microplastic and PFAS pollution. The plan includes regulations that limit the use of PFAS in food packaging and personal care products, as well as requirement for manufacturers to properly dispose of waste containing these chemicals. The government also invests in research to develop safer alternatives to PFAS and to improve wastewater treatment technologies. This demonstrates the power of government action in protecting the environment and human health. To further illustrate, consider the role of international agreements in addressing microplastic and PFAS pollution. These pollutants can travel long distances through air and water, meaning that they can affect countries far from their sources. International agreements and collaborations are needed to coordinate efforts to reduce the use of these pollutants, monitor their presence in the environment, and develop effective strategies for mitigating their impacts. By working together, countries can achieve more than they could alone in protecting the global environment. The need for a precautionary approach to microplastic and PFAS pollution is essential. Given the potential risks associated with these pollutants, it is important to take action to reduce their use and exposure, even if the full extent of the risks is not yet known. This means erring on the side of caution and taking steps to prevent pollution before it occurs. This includes adopting safer alternatives to PFAS whenever possible, reducing our consumption of single-use plastics, and supporting policies that promote sustainability. Imagine a community that decides to ban the use of PFAS in firefighting foam, even though the risks of exposure are not fully understood. The community recognizes the potential for PFAS to contaminate drinking water supplies and decides to take a precautionary approach to protect public health. This demonstrates the importance of taking action to prevent pollution, even in the face of uncertainty. To further illustrate, consider the role of consumers in demanding safer products. By choosing to buy products that are free of PFAS and other harmful chemicals, consumers can send a message to manufacturers that they value their health and the environment. This can encourage manufacturers to develop and market safer products. The potential for biomimicry to inspire solutions to microplastic and PFAS pollution is significant. Biomimicry is the practice of looking to nature for inspiration in solving human problems. Nature has evolved ingenious solutions to many of the challenges we face, and we can learn from these solutions to develop more sustainable technologies and practices. This includes studying how natural systems filter water, how organisms break down waste, and how ecosystems maintain stability. Imagine a team of engineers who are designing a new water filtration system. They study how aquatic plants filter water and use this knowledge to develop a more efficient and sustainable filtration system. This demonstrates the potential of biomimicry to inspire innovative solutions to environmental problems. To further illustrate, consider the role of architects in designing buildings that mimic natural systems. Architects can design buildings that are energy efficient, water efficient, and that incorporate natural materials. This can help to reduce the environmental impact of buildings and create more sustainable communities. The importance of considering the life cycle of products in addressing microplastic and PFAS pollution is crucial. The life cycle of a product includes all stages from raw material extraction to manufacturing, use, and disposal. By considering the environmental impacts of each stage of the life cycle, we can identify opportunities to reduce pollution and promote sustainability. This includes designing products that are durable, reparable, and recyclable, as well as minimizing the use of hazardous materials in manufacturing. Imagine a company that conducts a life cycle assessment of its products. The company identifies that the manufacturing process is a major source of pollution and takes steps to reduce its environmental impact. The company also designs its products to be more durable and recyclable, reducing the amount of waste that ends up in landfills. This demonstrates the importance of considering the life cycle of products in promoting sustainability. To further illustrate, consider the role of consumers in making informed purchasing decisions. By choosing to buy products that are made from sustainable materials and that have a lower environmental impact, consumers can support companies that are committed to sustainability. The need for a systems thinking approach to addressing microplastic and PFAS pollution is essential. Systems thinking is a way of understanding complex problems by considering the interactions between different parts of the system. This means looking at the big picture and considering the interconnectedness of environmental, social, and economic factors. By adopting a systems thinking approach, we can develop more comprehensive and effective solutions to these challenges. This includes considering the impacts of our actions on different parts of the environment, the social and economic consequences of pollution, and the potential for feedback loops to amplify or mitigate the effects of our actions. Imagine a community that is developing a plan to reduce its carbon footprint. The community adopts a systems thinking approach and considers the interconnectedness of energy, transportation, and land use. The community develops a plan that includes strategies for reducing energy consumption, promoting sustainable transportation, and preserving natural areas. This demonstrates the importance of systems thinking in addressing complex environmental challenges. To further illustrate, consider the role of policymakers in adopting a systems thinking approach to environmental policy. Policymakers can consider the interconnectedness of different environmental issues and develop policies that address multiple problems simultaneously. This can lead to more effective and efficient solutions. The potential for artificial intelligence, AI, to assist in addressing microplastic and PFAS pollution is significant. AI can be used to analyze large data sets, identify patterns, and predict future trends. This can help us to better understand the sources, pathways, and impacts of these pollutants, as well as to develop more effective strategies for mitigating their effects. This includes using AI to analyze satellite imagery, to track the movement of microplastics in the ocean, to predict the transport of PFAS through the atmosphere, and to optimize the performance of wastewater treatment plants. Imagine a team of researchers who are using AI to analyze data from thousands of water samples. The AI system identifies patterns that would be difficult for humans to detect, such as correlations between PFAS levels and certain industrial activities. This information can be used to target pollution prevention efforts and protect public health. To further illustrate, consider the role of AI in optimizing the design of new materials that are biodegradable or that can effectively remove pollutants from the environment. AI can be used to simulate the properties of different materials and to identify the most promising candidates for further research and development. The importance of fostering a sense of hope and optimism in addressing microplastic and PFAS pollution is crucial. While these are serious challenges, it is important to remember that we have the knowledge, tools, and resources to solve them. By focusing on the positive steps that are being taken and the potential for future progress, we can inspire action and create a more sustainable future. This includes celebrating the successes of communities that are working to reduce pollution, highlighting the innovations that are being developed to address these challenges, and empowering individuals to take action in their own lives. Imagine a community that has successfully cleaned up a contaminated site and restored it to a healthy ecosystem. The community celebrates this achievement and uses it as an example to inspire other communities to take action. This demonstrates the importance of fostering a sense of hope and optimism in addressing environmental challenges. To further illustrate, consider the role of storytellers in sharing stories of hope and inspiration. By telling stories about people who are making a difference, we can inspire others to take action and create a more sustainable future. And so, as we drift off to sleep, let us remember that even in the face of daunting environmental challenges like microplastic and PFAS pollution, there is reason for hope. The journey towards a cleaner, healthier planet may be long and complex, but with continued research, innovation, collaboration, and individual action, we can make a real difference. Sleep soundly, knowing that even small changes can ripple outwards, creating a wave of positive change for our environment and future generations. May your dreams be filled with visions of a world where clean water flows freely, ecosystems thrive, and human health is protected from the harmful effects of these persistent pollutants. Good night, good night, and may your dreams be filled with the possibilities of a future where science and human ingenuity work together to create a world free from the threats of microplastics and forever chemicals. Let's delve a little deeper into the specific technologies and approaches that are being employed to tackle the challenges posed by microplastics and PFAS. One area of significant focus is the development of advanced filtration systems. Traditional water treatment plants are often not equipped to effectively remove these tiny pollutants, which can slip through conventional filters. Scientists and engineers are therefore working on innovative filtration methods that can capture even the smallest microplastics and PFAS molecules. These include nanofiltration, reverse osmosis, and activated carbon adsorption. Nanofiltration utilizes membranes with extremely small pores that can selectively remove contaminants based on their size and charge. Reverse osmosis, a more energy-intensive process, applies pressure to force water through a semi-permeable membrane, leaving behind virtually all contaminants. Activated carbon adsorption involves using porous carbon materials to bind pollutants to their surface, effectively removing them from the water. The effectiveness of these methods depends on various factors, such as the type and concentration of pollutants, the water quality, and the operating conditions of the treatment plant. Further research and development are needed to optimize these technologies and make them more cost-effective and scalable for widespread use. Imagine a future where every household has access to a point-of-use water filter that can reliably remove microplastics and PFAS, ensuring safe and clean drinking water for all. Beyond filtration, another promising area of research is bioremediation. This involves using microorganisms, such as bacteria and fungi, to break down or transform pollutants into less harmful substances. Some bacteria have been found to be capable of degrading certain types of plastics, while others can metabolize PFAS molecules. The challenge lies in identifying and engineering microorganisms that can effectively break down a wide range of pollutants under various environmental conditions. Researchers are exploring different strategies to enhance the bioremediation process, such as adding nutrients to stimulate microbial growth, optimizing the pH and temperature of the environment, and using genetic engineering to create more efficient pollutant-degrading microbes. Bioremediation offers a potentially sustainable and environmentally friendly approach to cleaning up contaminated sites, but it requires careful monitoring and management to ensure that the process does not produce any harmful byproducts. Think of bioremediation as a natural cleaning crew, working tirelessly to break down pollutants and restore the health of our ecosystems. Furthermore, scientists are investigating the use of advanced oxidation processes, EOPs, to break down PFAS molecules. EOPs involve using strong oxidants, such as ozone, hydrogen peroxide, or ultraviolet radiation, to react with pollutants and break them down into simpler, less harmful compounds. These processes are highly effective at destroying PFAS molecules, but they can be energy intensive and may produce some undesirable byproducts. Researchers are working on optimizing AOPs to minimize energy consumption and byproduct formation, making them more sustainable and cost-effective. Imagine AOPs as tiny demolition crews, breaking down complex PFAS molecules into harmless fragments. In addition to these technological solutions, it is essential to address the root causes of microplastic and PFAS pollution. This includes reducing the production and use of these materials, improving waste management practices, and promoting the development of safer alternatives. Many companies are now exploring the use of biodegradable plastics, which can break down naturally in the environment, reducing the risk of microplastic pollution. Governments are also implementing policies to restrict the use of PFAS in certain products and to require manufacturers to properly dispose of these chemicals. Consumer awareness and behavior also play a crucial role. By making informed choices about the products we buy and how we dispose of them, we can all contribute to reducing microplastic and PFAS pollution. Consider the simple act of choosing reusable water bottles and shopping bags instead of single-use plastic ones. These small changes, when adopted by many, can have a significant impact. The historical context of plastic production and the development of PFAS chemicals provides valuable insights into the origins of these pollution problems. Plastics were first developed in the late 19th and early 20th centuries as a revolutionary new material that could be molded into almost any shape and used for a wide range of applications. Their low cost, durability, and versatility quickly made them a popular choice for packaging, consumer goods, and industrial products. However, the widespread use of plastics has led to a massive accumulation of plastic waste in the environment, which is now breaking down into microplastics. Similarly, PFAS chemicals were developed in the mid-20th century for their unique properties, such as water and oil resistance. They were used in a wide range of products, including non-stick cookware, firefighting foam, and stain-resistant fabrics. However, it was later discovered that PFAS are highly persistent in the environment and can accumulate in human and animal tissues, posing a significant health risk. Understanding the historical context of these materials helps us to appreciate the scale of the pollution problem and to develop more effective strategies for addressing it. The challenges posed by microplastics and PFAS are closely linked to other environmental issues, such as climate change, biodiversity loss, and water scarcity. Climate change is exacerbating the problem of microplastic pollution by increasing the frequency and intensity of storms and floods, which can carry microplastics into waterways and oceans. Biodiversity loss is also a concern, as microplastics and PFAS can harm aquatic organisms and disrupt food webs. Water scarcity is making it more difficult to treat contaminated water and to provide clean drinking water to communities. Addressing these interconnected environmental challenges requires a holistic approach that considers the complex interactions between different environmental systems. This includes promoting sustainable consumption and production patterns, investing in renewable energy, protecting biodiversity, and improving water management practices. Let's consider a specific example of how microplastic pollution is impacting marine life. Imagine a tiny zooplankton, a crucial component of the marine food web, mistakenly ingesting a microplastic particle. The microplastic can accumulate in the zooplankton's gut, preventing it from absorbing essential nutrients. This can weaken the zooplankton, making it more vulnerable to predators and less able to reproduce. As the zooplankton is consumed by larger organisms, such as fish, the microplastic can transfer up the food chain, potentially impacting the health of these animals as well. In addition, microplastics can act as carriers for other pollutants, such as heavy metals and organic chemicals, which can accumulate in the tissues of marine organisms. This can have a range of adverse effects, including reduced growth, impaired reproduction, and increased susceptibility to disease. The impact of microplastic pollution on marine life is a complex and ongoing area of research, but it is clear that these tiny pollutants pose a significant threat to the health of our oceans. Now, let's consider the potential human health effects of PFAS exposure. Studies have shown that exposure to certain PFAS can increase the risk of certain cancers, such as kidney and testicular cancer, as well as thyroid disease, liver damage, and immune system dysfunction. PFAS can accumulate in the body over time, particularly in the blood and liver. Infants and children are particularly vulnerable to the effects of PFAS exposure, as their developing bodies are more sensitive to these chemicals. Exposure to PFAS during pregnancy can also have adverse effects on fetal development. The health effects of PFAS exposure are a complex and evolving area of research, but it is clear that these chemicals pose a significant threat to human health. It is important to note that not all PFAS are equally toxic, and some PFAS have been phased out of production due to their potential health risks. However, many PFAS are still used in a wide range of products, and exposure to these chemicals is widespread. The role of citizen science in addressing microplastic and PFAS pollution is becoming increasingly important. Citizen scientists are volunteers who participate in scientific research, often by collecting data or analyzing samples. Citizen science projects can help to monitor microplastic and PFAS levels in the environment, to identify sources of pollution, and to evaluate the effectiveness of remediation efforts. These projects can also raise public awareness about these issues and encourage individuals to take action to reduce pollution. Imagine a group of citizen scientists collecting water samples from local streams and rivers, analyzing them for microplastics, and reporting their findings to researchers. This type of data collection can provide valuable insights into the extent of microplastic pollution in a particular area and can help to identify pollution hotspots. Citizen science provides a valuable opportunity for individuals to contribute to scientific research and to make a difference in their communities. The ethical considerations surrounding microplastic and PFAS pollution are also important to consider. These pollutants disproportionately impact vulnerable populations, such as low-income communities and indigenous communities, who may be more likely to live near sources of pollution or to have limited access to clean water. It is essential to ensure that all communities have access to clean water and a healthy environment, regardless of their socioeconomic status or geographic location. This requires a commitment to environmental justice and a recognition that everyone has the right to a safe and healthy environment. In addition, it is important to consider the long-term impacts of microplastic and PFAS pollution on future generations. We have a responsibility to protect the environment for future generations and to ensure that they have access to the same resources and opportunities that we do. This requires a long-term perspective and a commitment to sustainable practices. Let's further explore the role of international cooperation in addressing microplastic and PFAS pollution. These pollutants can travel long distances through the air and water, crossing national boundaries and impacting ecosystems and communities around the world. International cooperation is therefore essential to effectively address these challenges. This includes sharing information and best practices, coordinating research efforts, and developing international agreements to reduce pollution. The Stockholm Convention on Persistent Organopollutants, POPs, is an example of an international agreement that aims to eliminate or restrict the production and use of certain persistent pollutants, including some PFAS. International cooperation can help to ensure that all countries are working together to protect the environment and human health from the harmful effects of microplastic and PFAS pollution. The power of education and awareness in addressing these environmental challenges cannot be overstated. By educating the public about the sources, pathways, and impacts of microplastic and PFAS pollution, we can empower individuals to make informed choices and to take action to reduce pollution. This includes promoting sustainable consumption and production patterns, encouraging the use of reusable products, and supporting policies that reduce pollution. Educational programs can be targeted at different audiences, such as students, consumers, and policymakers. These programs can use a variety of methods, such as workshops, presentations, and online resources to raise awareness and to promote behavior change. Increased awareness can lead to a greater sense of responsibility and a willingness to take action to protect the environment. Think of the ocean as a vast, interconnected ecosystem, teeming with life and playing a crucial role in regulating the Earth's climate. Microplastic pollution is like a slow-acting poison, gradually accumulating in the ocean and harming marine organisms. The impact of this pollution can be far-reaching, affecting not only the health of the ocean, but also the livelihoods of people who depend on it for food and income. Similarly, PFAS pollution can contaminate drinking water sources, posing a direct threat to human health. These pollutants can persist in the environment for decades, making it difficult to clean up contaminated sites and to protect communities from exposure. Addressing these challenges requires a concerted effort from individuals, communities, governments, and industries. Consider the analogy of a leaky faucet. A single drip may seem insignificant, but over time, it can waste a significant amount of water and cause damage to the surrounding area. Microplastic and PFAS pollution are like a leaky faucet, with small amounts of these pollutants constantly entering the environment. Over time, these pollutants can accumulate and cause significant harm to ecosystems and human health. Just as we would fix a leaky faucet to prevent water waste, we need to take action to reduce microplastic and PFAS pollution and to protect our environment and our health. The journey towards a cleaner, healthier planet is a marathon, not a sprint. It requires sustained effort, perseverance, and a commitment to continuous improvement. There will be setbacks and challenges along the way, but we must not lose sight of our goal. By working together, we can create a future where clean water flows freely, ecosystems thrive, and human health is protected from the harmful effects of these persistent pollutants. Sleep soundly, knowing that even small changes can ripple outwards, creating a wave of positive change for our environment and future generations. May your dreams be filled with visions of a world where science and human ingenuity work together to create a more sustainable and equitable future for all. Let's explore the economic aspects of addressing microplastic and PFAS pollution. Cleaning up contaminated sites and treating contaminated water can be expensive, but the costs of inaction are even higher. The health costs associated with PFAS exposure, the economic losses from fisheries closures due to microplastic pollution, and the damage to ecosystems from these pollutants can all add up to significant economic burdens. Investing in pollution prevention and remediation can therefore be a cost-effective way to protect public health and to promote economic growth. This includes supporting research and development of cleaner technologies, implementing policies that reduce pollution, and investing in infrastructure to treat contaminated water and to manage waste. The potential for innovation in addressing microplastic and PFAS pollution is immense. Scientists and engineers are constantly developing new technologies and approaches to tackle these challenges. This includes developing biodegradable plastics, improving waste management practices, and creating more effective filtration and remediation technologies. Supporting innovation is crucial to finding sustainable solutions to these problems. This includes investing in research and development, providing incentives for companies to develop cleaner technologies, and fostering collaboration between scientists, engineers, and policymakers. Imagine a future where we have developed a closed-loop system for plastics, where all plastics are either recycled or biodegrade, eliminating the risk of microplastic pollution. The role of policy and regulation in addressing microplastic and PFAS pollution is critical. Governments can play a key role in setting standards, enforcing regulations, and providing incentives to reduce pollution. This includes setting limits on the amount of microplastics and PFAS that can be released into the environment, requiring manufacturers to properly dispose of these chemicals, and providing funding for research and remediation efforts. Effective policies and regulations can help to level the playing field and to ensure that all companies are taking steps to reduce pollution. It is important to note that policies and regulations should be based on sound science and should be regularly reviewed and updated to reflect new knowledge and technologies. Consider the analogy of a public health crisis. Microplastic and PFAS pollution can be viewed as a public health crisis, with potentially serious consequences for human health and the environment. Just as we would respond to a public health crisis with a coordinated effort to identify the source of the problem, to develop effective treatments, and to prevent future outbreaks, we need to take a similar approach to addressing microplastic and PFAS pollution. This requires a commitment to research, innovation, policy, and action. The long-term vision for a world free from the threats of microplastic and PFAS pollution is achievable. It requires a concerted effort from individuals, communities, governments, and industries. By working together, we can create a future where clean water flows freely, ecosystems thrive, and human health is protected from the harmful effects of these persistent pollutants. This vision is not just a dream. It is a goal that we can achieve through sustained effort, innovation, and collaboration. The story of microplastics and PFAS is a story of unintended consequences. These materials were developed for their beneficial properties, but their widespread use has led to significant environmental and health problems. This story serves as a reminder of the importance of considering the potential long-term impacts of new technologies and materials before they are widely adopted. It also highlights the need for a more precautionary approach to environmental protection, where we take action to prevent pollution even in the absence of complete scientific certainty. Let's explore the connection between microplastic and PFAS pollution and the principles of circular economy. A circular economy is an economic system that aims to minimize waste and to maximize the use of resources. This involves designing products for durability and recyclability, reducing the use of virgin materials, and recovering and reusing materials at the end of their life. Applying the principles of circular economy to plastics and PFAS can help to reduce pollution and to conserve resources. This includes developing biodegradable plastics, improving recycling rates, and finding alternative uses for these materials. The importance of transparency and public access to information in addressing microplastic and PFAS pollution cannot be overstated. The public has a right to know about the levels of these pollutants in their environment and the potential health risks associated with exposure. Governments and industries should be transparent about the data they collect and should make this information readily available to the public. This can help to empower individuals to make informed choices and to take action to protect their health and the environment. The role of art and storytelling in raising awareness about microplastic and PFAS pollution is often overlooked. Art and storytelling can be powerful tools for communicating complex scientific information and for inspiring action. This includes creating artwork from recycled materials, writing stories about the impacts of pollution on ecosystems and communities, and producing films and documentaries that raise awareness about these issues. Art and storytelling can help to connect people emotionally to these issues and to motivate them to take action. Imagine a world where we have successfully addressed the challenges of microplastic and PFAS pollution. The oceans are clean and teeming with life. The air is fresh and pure, and everyone has access to clean water. This is not just a utopian vision. It is a future that we can create through sustained effort, innovation, and collaboration. Sleep soundly, knowing that even small changes can ripple outwards creating a wave of positive change for our environment and future generations. The power of collective action in addressing these environmental challenges should not be underestimated. When individuals, communities, governments, and industries work together, we can achieve great things. This includes supporting policies that reduce pollution, investing in research and development, and making sustainable choices in our daily lives. Collective action can help to create a more sustainable and equitable future for all. The concept of environmental stewardship is central to addressing microplastic and PFAS pollution. Environmental stewardship is the responsibility of individuals and organizations to protect and care for the environment. This includes taking steps to reduce pollution, conserving resources, and promoting sustainable practices. Environmental stewardship is not just a moral obligation. It is also a practical necessity for ensuring the long-term health and well-being of our planet and its inhabitants. Let's delve a little deeper into the chemistry of PFAS. These compounds are characterized by a carbon-fluorine bond, which is one of the strongest chemical bonds known. This strong bond makes PFAS highly resistant to degradation, which is why they persist in the environment for so long. The length of the carbon chain and the type of functional group attached to the chain can affect the properties and toxicity of different PFAS compounds. Some PFAS, such as PFOS and PFOA, have been shown to be particularly harmful to human health and the environment. The development of analytical methods for detecting and quantifying microplastics and PFAS in the environment is crucial for monitoring pollution levels and for assessing the effectiveness of remediation efforts. This includes developing sensitive and accurate methods for measuring these pollutants in water, soil, air, and biota. These methods often involve sophisticated analytical techniques, such as gas chromatography mass spectrometry, GCMS, and liquid chromatography mass spectrometry, LCMS. The data generated from these analyses can be used to track the movement of these pollutants through the environment and to identify potential sources of contamination. Consider the analogy of a detective solving crime. Scientists are like detectives, using their knowledge and skills to investigate the mysteries of microplastic and PFAS pollution. They collect evidence, analyze data, and try to piece together the puzzle of how these pollutants are impacting the environment and human health. Just as a detective needs to be thorough and persistent to solve a crime, scientists need to be dedicated and innovative to address these environmental challenges. The importance of interdisciplinary collaboration in addressing microplastic and PFAS pollution cannot be overstated. Scientists, engineers, policymakers, and community members need to work together to develop effective solutions to these problems. This includes sharing knowledge, coordinating research efforts, and developing policies that are based on sound science and that meet the needs of communities. Interdisciplinary collaboration can help to ensure that we are addressing these challenges in a holistic and sustainable way. Imagine a future where we have developed a truly sustainable system for managing plastics and chemicals. This system is based on the principles of circular economy, environmental stewardship, and social justice. It is a system that protects the environment, promotes human health, and provides economic opportunities for all. This future is within our reach, but it requires a commitment to innovation, collaboration, and action. Sleep soundly, knowing that even small changes can ripple outwards, creating a wave of positive change for our environment and future generations. And so, as the stars twinkle above and the world slumbers, let us hold on to the hope that a brighter, cleaner future is not just a possibility, but a promise we can actively create. Let the gentle rhythm of your breath guide you into a peaceful sleep, filled with dreams of a world where science, nature, and humanity coexist in harmony. Good night. Let's explore some specific examples of innovative technologies being used to combat microplastic pollution. One such technology is the use of bubble barriers in rivers and waterways. These barriers consist of a perforated pipe placed at the bottom of the water body, which releases a continuous stream of air bubbles. The bubbles rise to the surface, creating a current that deflects microplastics towards the riverbank, where they can be collected and removed. Bubble barriers are a relatively low-cost and environmentally friendly way to prevent microplastics from flowing into the ocean. Another promising technology is the development of magnetic microplastics. These are microplastics that have been coated with a magnetic material, allowing them to be easily removed from water using magnets. This technology is still in the early stages of development, but it has the potential to be a highly effective way to clean up microplastic pollution. Imagine a fleet of tiny robots equipped with magnets, scouring the oceans and rivers, collecting microplastics and restoring the health of our waterways. Let's also consider the potential of using enzymes to break down plastics. Enzymes are biological catalysts that can speed up chemical reactions. Scientists have discovered enzymes that can break down certain types of plastics, such as PET, into their constituent monomers. This technology is still in its early stages of development, but it has the potential to be a game changer in the fight against plastic pollution. Imagine a future where we can use enzymes to recycle all types of plastics, creating a closed-loop system that eliminates waste. In addition to technological solutions, it is important to address the behavioral aspects of microplastic and PFAS pollution. This includes promoting sustainable consumption patterns, encouraging the use of reusable products, and reducing the amount of waste we generate. Simple changes in our daily habits can have a significant impact on reducing pollution. Consider the simple act of refusing single-use plastic straws or bringing your own reusable bags to the grocery store. These small changes, when adopted by many, can make a big difference. The role of education in promoting behavior change is crucial. By educating the public about the sources, pathways, and impacts of microplastic and PFAS pollution, we can empower individuals to make informed choices and to take action to reduce pollution. This includes teaching children about the importance of recycling and reducing waste, and providing adults with the information they need to make sustainable choices in their daily lives. Let's explore the connection between microplastic and PFAS pollution and the concept of environmental justice. Environmental justice is the fair treatment and meaningful involvement of all people regardless of race, color, national origin, or income with respect to the development, implementation, and enforcement of environmental laws, regulations, and policies. Microplastic and PFAS pollution disproportionately impact vulnerable populations, such as low-income communities and communities of color, who may be more likely to live near sources of pollution or to have limited access to clean water. Addressing these environmental injustices requires a commitment to equity and fairness. The importance of community engagement in addressing microplastic and PFAS pollution cannot be overstated. Communities that are affected by these pollutants should be involved in the decision-making process and should have a voice in the development of solutions. This includes providing communities with access to information, opportunities for participation, and resources to address these challenges. Imagine a community that has successfully cleaned up a contaminated site and restored it to a healthy ecosystem. The community celebrates this achievement and uses it as an example to inspire other communities to take action. This demonstrates the power of community engagement and the importance of celebrating successes. The challenges posed by microplastic and PFAS pollution are complex and multifaceted, but they are not insurmountable. By working together, we can create a cleaner, healthier, and more sustainable future for all. Sleep soundly, knowing that even small changes can ripple outwards, creating a wave of positive change for our environment and future generations. And so, as you drift off to sleep, let your mind wander to the possibilities of a world where science, technology, and human ingenuity are harnessed to protect our planet and to ensure a healthy future for all. Let your dreams be filled with visions of clean oceans, clear skies, and thriving ecosystems. Good night. Let's consider the ethical implications of developing and using new technologies to address microplastic and PFAS pollution. It is important to ensure that these technologies are safe, effective, and affordable, and that they do not have any unintended consequences. It is also important to consider the potential impacts of these technologies on different communities and to ensure that they are used in a fair and equitable way. The precautionary principle is a guiding principle in environmental decision-making. The precautionary principle states that when an activity raises threats of harm to human health or the environment, precautionary measures should be taken even if some cause and effect relationships are not fully established scientifically. This principle is particularly relevant to microplastic and PFAS pollution, where there is still much that we do not know about the long-term impacts of these pollutants. The concept of planetary boundaries is also relevant to microplastic and PFAS pollution. Planetary boundaries are a framework that defines a safe operating space for humanity based on the Earth's biophysical systems. Exceeding these boundaries can lead to abrupt and irreversible environmental changes. Microplastic and PFAS pollution are contributing to the transgression of several planetary boundaries, including those related to biodiversity loss, chemical pollution, and climate change. Imagine a world where we have successfully restored the health of our planet and have created a sustainable future for all. This is a future that is worth striving for, and it is a future that we can achieve through sustained effort, innovation, and collaboration. Sleep soundly, knowing that even small changes can ripple outwards, creating a wave of positive change for our environment and future generations. And so, as the night deepens and the world grows still, let us remember the importance of protecting our planet and of creating a sustainable future for all. Let your dreams be filled with visions of a world where science, nature, and humanity coexist in harmony. Good night. Let's further explore the role of international agreements in addressing microplastic and PFAS pollution. The Basel Convention on the Control of Transboundary Movements of Hazardous Wastes and Their Disposal is an international agreement that aims to regulate the transboundary movement of hazardous wastes, including plastic waste. This convention can help to prevent plastic waste from being shipped to developing countries, where it may be improperly disposed of. The Minamata Convention on Mercury is another international agreement that is relevant to microplastic and PFAS pollution. This convention aims to protect human health and the environment from the adverse effects of mercury. Mercury can accumulate in microplastics and can be transferred up the food chain, posing a threat to human health. Imagine a world where all countries are working together to protect the environment and to ensure a sustainable future for all. This is a world that is possible, but it requires a commitment to international cooperation and collaboration. Sleep soundly, knowing that even small changes can ripple outwards, creating a wave of positive change for our environment and future generations. And so, as the moon shines brightly in the sky, let us reflect on the importance of protecting our planet and of creating a sustainable future for all. Let your dreams be filled with visions of a world where science, nature, and humanity coexist in harmony. Good night. The role of technology transfer in addressing microplastic and PFAS pollution is often overlooked. Technology transfer involves the sharing of knowledge, skills, and technologies between different countries and organizations. This could be particularly important for developing countries, which may lack the resources and expertise to address these challenges on their own. Technology transfer can help to accelerate the development and deployment of cleaner technologies and to promote sustainable practices around the world. The importance of capacity building in addressing microplastic and PFAS pollution cannot be overstated. Capacity building involves strengthening the skills, knowledge, and resources of individuals and organizations to address these challenges. This includes providing training, education, and technical assistance to scientists, engineers, policymakers, and community members. Capacity building can help to ensure that all countries have the capacity to address microplastic and PFAS pollution effectively. Imagine a world where all communities have the resources and expertise to protect themselves from the harmful effects of microplastic and PFAS pollution. This is a world that is possible, but it requires a commitment to capacity building and technology transfer. Sleep soundly, knowing that even small changes can ripple outwards, creating a wave of positive change for our environment and future generations. And so, as the stars twinkle above and the world slumbers, let us hold on to the hope that a brighter, cleaner future is not just a possibility, but a promise we can actively create. Let the gentle rhythm of your breath guide you into a peaceful sleep, filled with dreams of a world where science, nature, and humanity coexist in harmony. Good night. Let's conclude with a final thought. The journey towards a cleaner, healthier planet is a shared responsibility. Every action, no matter how small, can make a difference. By working together, we can create a future where clean water flows freely, ecosystems thrive, and human health is protected from the harmful effects of microplastics and forever chemicals. Sleep well, knowing that you are part of the solution. Good night. The collaborative spirit extends beyond national borders. International organizations, such as the United Nations Environment Program, UNEP, and the World Health Organization, WHO, play a crucial role in coordinating global efforts to address microplastic and PFAS pollution. These organizations facilitate the sharing of scientific information, promote the development of international standards and regulations, and provide technical assistance to countries in need. Their work is essential for ensuring a coordinated and effective global response to these environmental challenges. Think of them as the conductors of a global orchestra, harmonizing the efforts of different nations to create a symphony of environmental protection. Just as an orchestra requires skilled musicians and a clear score, addressing microplastic and PFAS pollution requires dedicated scientists, effective policies, and a shared understanding of the problem. The importance of education and public awareness in addressing microplastic and PFAS pollution cannot be overstated. Many people are simply unaware of the potential risks associated with these pollutants. By raising awareness of the problem, we can empower individuals to make informed choices and to take action to reduce their own exposure. This includes supporting policies that promote sustainable practices, reducing our consumption of single-use plastics, and choosing products that are free of PFAS. Education can also inspire the next generation of scientists, engineers, and policymakers to dedicate their careers to finding solutions to these environmental challenges. Imagine a world where every child learns about the importance of protecting our planet and of living sustainably. This is a world that is within our reach, but it requires a commitment to education and public awareness. The role of citizen science in addressing microplastic and PFAS pollution is becoming increasingly important. Citizen science involves engaging members of the public in scientific research. This can include collecting samples, analyzing data, and reporting observations. Citizen science projects can provide valuable data on the extent and distribution of microplastic and PFAS pollution and can help to raise awareness of the problem. They can also empower individuals to feel like they are making a real difference in addressing these challenges. Think of citizen scientists as the eyes and ears of the environmental community, providing valuable information that would otherwise be difficult to obtain. Just as a community watch program can help to deter crime, citizen science projects can help to monitor and protect our environment. Consider the example of a citizen science project that involves collecting water samples from local streams and rivers. Participants are trained to collect samples using a standardized protocol and to analyze them for the presence of microplastics. The data collected by citizen scientists can then be used to create maps of microplastic pollution and to identify sources of contamination. This information can be used to inform policy decisions and to guide remediation efforts. This also fosters a sense of community ownership and responsibility towards environmental protection. It turns passive observers into active participants in the solution. Another area of crucial importance is the development of innovative technologies for removing microplastics and PFAS from water and soil. Scientists and engineers are working on a variety of promising technologies, including filtration systems, advanced oxidation processes, and bioremediation techniques. These technologies have the potential to significantly reduce the levels of these pollutants in the environment. However, further research and development are needed to improve their effectiveness and to reduce their cost. Imagine a future where we have highly efficient and cost-effective technologies for cleaning up microplastic and PFAS pollution. This is a future that is possible, but it requires continued investment in research and development. For instance, advanced oxidation processes, EOPs, use powerful oxidants, such as ozone or hydrogen peroxide, to break down PFAS molecules into less harmful substances. These processes can be highly effective, but they can also be energy-intensive and expensive. Bioremediation techniques, on the other hand, use microorganisms to break down pollutants. These techniques can be more sustainable and cost-effective, but they may be slower and less effective for certain types of pollutants. The ideal solution may involve a combination of different technologies tailored to the specific characteristics of the contaminated site. The development of sustainable alternatives to plastics and PFAS is also essential for preventing future pollution. This includes developing new materials that are biodegradable or compostable, as well as finding safer alternatives to PFAS in a variety of products. Many companies are already working on these types of alternatives, but more research and development is needed to make them widely available and affordable. Imagine a world where all of the products we use are made from sustainable materials that do not harm the environment. This is a world that we can create, but it requires a concerted effort from industry, government, and consumers. Consider the example of bioplastics, which are plastics made from renewable resources, such as cornstarch or sugarcane. Bioplastics can be biodegradable or compostable, which means that they can break down naturally in the environment. However, not all bioplastics are created equal. Some bioplastics require specific conditions to break down, such as high temperatures or specific types of microbes. Other bioplastics are not biodegradable at all. It is important to carefully evaluate the environmental impact of different types of bioplastics before using them as replacements for traditional plastics. Furthermore, the land use and resources required for growing the crops to produce bioplastics also needs careful consideration to ensure true sustainability. The importance of international collaboration in addressing microplastic and PFAS pollution cannot be overstated. These pollutants do not respect national borders, and their impacts are felt around the world. To effectively address these challenges, we need to work together to share knowledge, develop common standards, and implement coordinated policies. This includes supporting international agreements, such as the Stockholm Convention on Persistent Organic Pollutants, which aims to eliminate or restrict the production and use of certain hazardous chemicals, including some PFAS. Imagine a world where all countries are working together to protect our oceans and to ensure that all people have access to clean water. This is a world that is possible, but it requires a commitment to international cooperation and collaboration. Sleep soundly, knowing that even small changes can ripple outwards, creating a wave of positive change for our environment and future generations. Think of it as a global puzzle where each nation holds a piece. Only by working together can we assemble the complete picture and find effective solutions. The role of responsible waste management is paramount in mitigating the spread of microplastics and PFAS. Improving waste collection, sorting, and recycling infrastructure, particularly in developing countries, is crucial. Investing in technologies that can efficiently remove microplastics from wastewater treatment plants is also essential. Moreover, reducing the amount of waste generated in the first place through promoting reusable products and reducing packaging can significantly decrease the input of these pollutants into the environment. We need to shift from a linear take, make, dispose economy to a circular economy where resources are used and reused, minimizing waste and pollution. Think of waste management as the last line of defense against pollution. Just as a well-maintained dam can prevent flooding, effective waste management systems can prevent microplastics and PFAS from entering our waterways and ecosystems. However, this line of defense is only as strong as its weakest link. If waste is not properly collected, sorted, and treated, it can easily end up in the environment, causing significant harm. Therefore, implementing extended producer responsibility (EPR) schemes, where manufacturers are responsible for the end-of-life management of their products, can incentivize the design of more sustainable products and improve waste management practices. This shifts the burden of waste management from taxpayers to producers, creating a financial incentive for companies to reduce waste and use more sustainable materials. This approach fosters innovation and encourages companies to take a more holistic view of their products' environmental impact, from design to disposal. Furthermore, the development and adoption of green chemistry principles is crucial in preventing the introduction of new hazardous chemicals, including PFAS, into the environment. Green chemistry focuses on designing chemical products and processes that minimize or eliminate the use and generation of hazardous substances. This includes using safer solvents, catalysts, and feedstocks, as well as designing products that are biodegradable or recyclable. By embracing green chemistry, we can reduce the risk of future environmental contamination and create a more sustainable chemical industry. Think of green chemistry as the proactive approach to preventing pollution, while traditional environmental remediation is the reactive approach to cleaning it up. Just as preventative medicine is more effective and less costly than treating disease, green chemistry is more effective and less costly than cleaning up pollution. By designing safer chemicals and processes from the start, we can avoid the need for expensive and time-consuming remediation efforts in the future. The implementation of stricter regulations and enforcement is also critical in controlling microplastic and PFAS pollution. This includes setting limits on the amount of these pollutants that can be discharged into the environment, as well as establishing monitoring programs to ensure compliance. Strong enforcement mechanisms are needed to deter companies from violating these regulations and to hold them accountable for their actions. Transparency and public access to information are also essential for ensuring that regulations are effectively implemented and enforced. Imagine a world where all companies are held accountable for the environmental impact of their products and processes. This is a world that is possible, but it requires strong regulations, effective enforcement, and a commitment to transparency. Sleep soundly, knowing that even small changes can ripple outwards, creating a wave of positive change for our environment and future generations. Think of regulations as the guardrails on a highway, preventing vehicles from veering off course and causing accidents. Without these guardrails, the highway will be much more dangerous. Moreover, addressing the legacy of PFAS contamination is a significant challenge. Many sites around the world are contaminated with PFAS from past industrial activities and the use of firefighting foam. Cleaning up these sites can be extremely expensive and technically complex. However, it is essential to protect human health and the environment. This requires a long-term commitment to remediation and a willingness to invest in innovative technologies. The polluter pays principle should be applied whenever possible, ensuring that those responsible for the contamination bear the cost of cleanup. Think of PFAS contamination as a hidden burden that weighs on our communities and ecosystems. Just as a chronic illness can drain our energy and resources, PFAS contamination can drain our economy and damage our environment. Addressing this legacy requires a long-term commitment to healing and restoration. Finally, remember that individual actions can make a significant difference in reducing microplastic and PFAS pollution. By making conscious choices about the products we buy, the waste we generate, and the way we live, we can all contribute to a cleaner and healthier planet. This includes reducing our consumption of single-use plastics, choosing products that are free of PFAS, and supporting policies that promote sustainability. Every small action counts, and together we can create a brighter future for generations to come. Imagine a world where everyone is committed to protecting our planet and living sustainably. This is a world that is within our reach, but it requires a collective effort from all of us. Sleep soundly, knowing that even small changes can ripple outwards, creating a wave of positive change for our environment and future generations. Think of individual actions as drops of water that, when combined, can create a powerful river. Each drop may seem insignificant on its own, but together they can shape the landscape and nourish life. As you drift off to sleep, visualize a world where clean water flows freely, ecosystems thrive, and human health is protected from the harmful effects of microplastics and forever chemicals. This vision can inspire you to take action and to make a difference in your own life. and in the world around you. Good night. And remember, the pursuit of scientific understanding and environmental stewardship is a journey, not a destination as you drift off. Consider the power of scientific inquiry. Every experiment, every observation, every hypothesis tested is a step forward in our understanding of the world. Think of scientists as detectives, piecing together clues to solve the mysteries of nature. Just as a detective uses forensic science to uncover the truth, scientists use environmental chemistry to understand the impact of pollutants on our planet. The dedication and curiosity of researchers are essential to finding solutions to complex environmental problems like microplastic and PFAS contamination. And remember, even though the challenges we face may seem daunting, there is always hope for the future. New technologies are being developed all the time to remove microplastics and PFAS from water and soil. Scientists are also working on developing safer alternatives to PFAS that do not persist in the environment. The field of environmental remediation is constantly evolving, and there is reason to be optimistic about our ability to clean up contaminated sites and protect human health. Imagine the future generations who will benefit from our efforts to create a cleaner and healthier planet. This is a legacy worth striving for, a future where clean water and healthy ecosystems are a reality for all. Think of environmental remediation as a form of restorative justice, righting the wrongs of the past and creating a more sustainable future for all. The story of environmental chemistry is not just about pollution and contamination. It is also a story about innovation, resilience, and hope. It is a reminder that we have the power to create a better world, one discovery, one innovation, one conscious choice at a time. As you close your eyes, let this thought bring you peace and inspire you to be a part of the solution. Envision a world where science and sustainability go hand in hand, guiding us towards a brighter and healthier future for all. Sleep well.